Hi, I'm Dr. Eugene O'Loughlin and welcome to this lesson on problem-solving techniques. In this lesson, we're going to take a look at PERT analysis. So let's take a look at our objectives for this lesson. At the end of the lesson, you should be able to, first of all, define what is meant by PERT analysis, use this analysis to create a three-point estimate of activity duration, and finally, combine PERT analysis with project network diagrams to estimate activity and project duration. In our curriculum, we're in section 5, which is about resource planning, and in this section we have 3 problem-solving techniques, and the third of these is PERT analysis. So as before, let's start off our lessons with an inspiring quote. Lord Chesterfield, who was the 4th Earl of Chesterfield, a British statesman and man of letters, once said, "Take care of the minutes and the hours will take care of themselves." So we need to be careful about estimating time, and PERT analysis is one of those methods to help us be more careful with predicting time. So first of all, PERT analysis stands for Program Evaluation Review Technique, PERT, and it's very closely associated with project network diagrams and in turn Gantt charts. So this is our project network diagram here on the right hand side, and this was the subject of a previous lesson, and we went through it, and in that lesson we mentioned PERT analysis, and this is what this particular lesson here is now about. So PERT analysis is very useful for helping us estimate activity durations. We saw in our project network diagram, like the one at the bottom right here, that each activity, which is a letter on an arrow, so this is the activity on arrow method, each activity is given a duration, okay? And so how do we estimate that? And so like a project manager will use this information to create a Gantt chart and a schedule for a project. So he or she will need to know the duration of each task on that chart. So instead of providing activity estimates as a discrete number, for example 4 weeks, it's often helpful to create a 3-point estimate, and this really comes into its own when there's disagreement over how long an activity is going to take. So you've asked 3 different people to come up with an estimate of an activity, and one gives you an optimistic time, another gives you a most likely time, and a third person gives you a pessimistic estimate. So 3 different estimates. You can only put one in the diagram. Which one do you put down? So in this one here we can see activity F does not have a duration because there's some dispute or some doubt about that, or perhaps it's a high-risk task that we're uncertain will be completed in a particular time, but we need to put a time on this diagram. So project time management is a discipline which most of this is involved with. We need to understand the time needed to complete every task, and also then in turn gives us the minimum time needed to complete the total project. And this is where, as we saw in our project network diagram lesson, where things like the critical path comes to the fore. So PERT analysis incorporates uncertainty, and if there's any doubt or if there's disagreement. We use it to schedule a project without accurate details and durations of all activities. So as I said, I did mention that, on our diagram, if we've got 3 different estimates, we can only put one down. So what is the one that we're going to use? So PERT analysis is a fairly straightforward technique. Mostly use Excel to do it. It can be done by hand, but most people will use Excel to do it. So it's a network analysis technique used to estimate project duration or the tasks within that project, and most often used when there's a high degree of uncertainty about the individual activity duration estimates. So let's take a look at this small example over here from Excel. We can see that we've got 3 estimates. Our optimistic time, and the estimates are in working days. The optimistic time is that a particular task will be completed in 1 day. The most likely time is that it'll be completed in 2 days. Now this might be based on that you have an experienced team, they know what they're doing, or it's similar to a task that was completed before, or you did the same task the previous year, whatever. So it's most likely time. But we also get a pessimistic time. Perhaps there's some new people on your team, or there's some uncertainty or some risk or resource issues that might influence the duration. And so I've got 1 day, 2 days, and 9 days. And which one of these do I put in? So I take this formula that I have on the bottom of my page here. We look at it more closely now in a moment, where it takes into account the optimistic time, the most likely time, and the pessimistic time. So we've got a formula here to work out what we call our PERT weighted average. So let's take a look at that a little bit closer. This is the formula you're most likely to see and use. The OT, which is our optimistic time, that's added to 4, and we multiply that then by the most likely time, MLT, and then add the PT, which is the pessimistic time. And then once that's done, we divide that by 6. Now when you're doing this, and be going through this in the how-to video for this section. We need to be careful with precedence and so on in this formula. But this is the way it should work out. So when I take my information here from the example I looked at a few moments ago, the optimistic time of 1 day, 2 days for most likely time, and 9 days for most pessimistic time, I'm going to now put these into my formula. So we can see here 1 work day for optimistic time, plus 4, multiplied by most likely time, which is 2 days, plus 9, which is the pessimistic time. So when I work all of that out, divided by 6, I come up with the answer of 3 work days, and that's what I've worked out here on the Excel sheet. You can see the formula in the formula bar that I've typed in to do this, and just put brackets over the top part of the formula to make sure precedence is okay. So now, with using my formula giving us a PERT weighted average of 3 work days, I'm now in a position to put a duration for task F on my diagram. So I haven't put down 1, I haven't put down 2 or 9, I put down 3 work days based on the PERT analysis. In our assignment for this section here, a little bit more elaborate, I'm going to combine calculations for PERT analysis and project network diagrams. So I'm going to provide you with this spreadsheet in the assignment, and I've got several activities listed here on the left hand side. I've got the dependencies so that you can work out the project network diagram, and you can see here I've got my optimistic times, most likely times, and pessimistic time for each of the tasks listed over here on the left hand side. So I want you to fill out this column with the PERT weighted average for each one. It should be straightforward to do once you've worked out the first one. Do note that your answer is always going to be greater than the optimistic time and less than the pessimistic time. So if I get an answer here of a PERT weighted average of say 15, I know I have made a mistake using the formula. And then in Excel, then we can copy all of that down. And then using the PERT weighted average times, we can then draw up the project network diagram. So in summary, PERT analysis is used to create a 3-point estimate that includes an optimistic, most likely, and pessimistic estimate. So you've got a problem, you don't know how long an activity is going to take or how long a task is going to amount to in hours or days. A PERT formula is useful for giving us an actual number. And the formula for calculating PERT is the optimistic time plus 4 multiplied by most likely time plus a pessimistic time divided by 6. That gives us our PERT weighted average that we can then use on things like our project network diagram, and in turn will end up on Gantt charts and on schedules. So that's how you use PERT analysis in problem solving techniques. I hope you found this video useful.